Welcome to 5-6, least common multiples. Our objective today is to find the least common multiple of two or more numbers. Our second objective is to find the least common denominator of two or more fractions. Alright, before we begin, let's talk about some of the key terms. First off is a multiple. A multiple of a number is a product of that number and a whole number. Our next key term is common multiples. Common multiples is when numbers have the same multiples. When comparing numbers like 4 and 6 here, and we list our multiples together, we can see a series of common multiples like 0, 12, and 24. We call those common multiples. Our next key term, least common multiples. Our LCM is the least of the non-zero common multiples. This is what we're really interested in when we're comparing two or more numbers and looking at their common multiples. We're looking for the least. In this case, it is 12. The reason it isn't zero is because we're always looking for the non-zero in this case. If we kept on going with multiples of 4 and 6, we could get so many of them. But once again, the name of it is the least, so we're looking for the smallest. We use this least common multiple idea when we use least common denominator. It's actually the LCM. We're going to look at two denominators. Right now we have 2 and 8. And in order to add them together or subtract them, we really need to have the same denominator. So we're going to use this concept of least common multiple, which is the same as least common denominator. And we're going to find out what 2 and 8 have in common. You can see here we have listed out 2, 4, 6, 8. And we listed out the multiples of 8. And once again, I left the 0 out because we're looking for a non-zero. And the least of them is 8. So the LCD of 1/2 and 3/8 is 8. It asks on this slide to find the LCM of 108 and 240. Well, we're going to have to go back to a skill that we learned a while ago, and that is the prime factorization of 108 and 204. Alright, I skipped the prime factorization tree, but I have 108, and it's 2 times 2 times 3 times 3 times 3. Notice that all these are prime numbers, and we need that to use to find out the LCM. I've listed all the prime factorizations of 240, 2 times 2 times 2 times 2 times 3 times 5. Alright, what I'm going to do is put these in using exponents. Putting them in exponents is to help me compare them. I know that the prime factors are prime numbers in both of them are 2, 3, and 5. It doesn't matter that 5 is not in 108. What we're looking for is all the numbers, or all the prime numbers being used in both of them. So 2. I compared the 2 to the squared and 2 to the 4th, and I'm going to take the largest of the two. Now I'm going to look at the prime number 3, and I'm going to pick the largest of the two, and that's 3 to the 3rd. And 5, well, there's nothing to compare it to, so I'm going to take 5 to the 1st. I'm going to multiply 2 to the 4th times 3 to the 3rd times 5. My calculator says 2,160. That is the LCM. Alright, let's do that again. We'll find the LCM of 18 times xy squared and 10y. These are two monomials, or algebraic expressions. You can see here that I took 18 xy squared. I found the prime factorization of 18, 2 times 3 times 3, and I put it in with exponents, so now you see I have 2 times 3 squared times x times y squared. I did the same for 10y. I found the prime factorization. I didn't need to use exponents because there's only 1, 2, and 1, 5, and 1 y. Now I'm going to list all the primes. I have 2 times 3 times 5 times x times y. Now, when I compare the 2's, and I notice that both of them are 2 to the first power, so I'm going to keep it as 2 to the first power. I look at the 3, and there's only one of them, that's 3 squared, so I'm going to use 3 squared. There's only one 5, that's 5 to the first power, I'm going to keep that. I look at the x, there's nothing to compare it to, so I'm going to keep the x to the first power. I have 2 y's, y to the square is the largest, so I'm going to keep that one. So now to find the LCM, I'm going to multiply this all together, and the LCM of 2 times 3 squared times 5 times x times y squared is, the answer is 90 times x times y squared. Now on this slide, we're not finding the LCM, we're finding the LCD, so we're looking for the lowest common denominator of 9 and 21. You can see I did the prime factorization of 9, which is 3 squared. I did the prime factorization of 21, which is 3 times 7. Now I was trying to find the LCD, not the M. I find that we have 2 3's. I'm going to choose the largest, which is 3 squared. And there's only one 7, and the largest is 7. So the LCD of 9 and 21 is 63. Alright, in this slide we have the LCD again. This time we have algebraic expressions. You can see our denominators here, 12b squared and 8ab. Alright, I did the prime factorization of our 2 denominators. You can see here that I got 2 squared times 3 times b squared for 12b squared. Then I got 2 to the third power times a times b for 8ab. Now it's time to find the LCD. Look at my prime factorization. They both have 2. The largest is 2 to the third, so I choose that one. Looking at the 2, I notice that there's only a 3, so I'm going to choose that one. That's 3 to the first power. Looking at the 2 numbers, the prime factorization, I notice that only one of them has a, and that's a to the first, so I'm going to choose that one. And then last, I have b. I look at both numbers, and b squared is the largest. So now I'm going to go ahead and multiply these together, and I get 24ab squared. In a previous lesson, we compared 2 fractions together, and we changed the fractions into decimals. There is another method. Sometimes it's quicker, sometimes it isn't. And that is to find LCDs of our fractions and then compare the numerators together. So let's look at 1/6 and 7 over 15. You can see the denominator of 6 has a prime factorization of 2 times 3, and 15 has 3 times 5. So now let's see what the LCD is. 6 has a 2. They both have a 3. The highest is 3 to the first power. 15 has a 5, and that's to the first power. I go ahead and multiply them together, and my LCD is 30. Now we're going to use that to compare the 2 fractions. You can see our first fraction, 1/6. The denominator is supposed to be 30 because that's the LCD. I set it up so I'm going to multiply 1/6 by another fraction where the denominator is going to equal 30. What can I multiply 6 by that it equals 30? Well, that's 5. Now, whatever we do on the bottom, we got to do on the top. So 5 over 5 is what we're going to use to convert our fractions so they have the like denominators. So 1/6 gets changed to 5 over 30. Now we're going to do the same thing to 7 over 15. 15 times what equals 30? And we say to ourselves that's 2. And whenever we do this, whatever we do on the bottom, we do on the top. So 2 over 2. It's like multiplying by 1. 2 times 7 is 14. Alright, now we have 2 fractions with the same denominator. Let's compare them. Looking at these 2 fractions, it looks like 14 over 30 is larger. So now it's time to answer the question. Using the original numbers in the problem, 1/6 is less than 7 over 15. I replace the gray circle with an inequality, and there's our answer.